All right, so I think this is recording. Let's take a look here at these three problems. Now, I didn't cut and paste the directions. They were the same as the directions of the previous three, and that's to find the discriminant and use the discriminant to determine the number and the type of solutions that we have here. So let's take a look at this number 4. It's not in standard form, so that's the first thing we want to do is rewrite this in standard form so that we can identify A, B, and C. Subtract 2 from each side. Now I notice that all of these are divisible by 3, so I'm going to go ahead and divide each one by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. And 0 divided by 3 is 0. So our constants A, B, and C, this A is not the same as the variable, so be careful about that. So the quadratic formula tells us that the solution to this equation, that A is the variable, and most of the time we write X there, but in this case it was given to us as a different variable. The opposite of B, the opposite of 4 is negative 4. Excuse me, I don't want to actually plug it in because they didn't have me solve it. I just want to write down the formula for you because I want to reference this discriminant. This is the number that I really want to calculate, the b squared minus 4ac. And I'm writing that underneath the radicals to help you recognize that how we determine the type of solution. So if we come in and find this number, this b squared minus 4ac, we've already identified a, b, and c. So b squared, 4 squared is 16, minus 4 times a is 1, and c is 4, and this is 0. So with the discriminant of 0, you have a solution of the opposite of b plus or minus 0, because the square root of 0 is 0. So this tells us that we're going to have one rational solution. And because that exponent is a 2, you'll see people often emphasize that one solution is a repeated solution. Because our quadratic equations, we don't have to worry about extraneous solutions with our quadratic equations. All right, so here's our answer for number 4. The discriminant was 0. There was one solution, and the type of that solution was a rational solution. Let's shrink this up and take a look at number 5. All right. Number 5 is not in standard form, so let's rewrite it in standard form. We've got 5y squared minus 4y plus 2 is equal to 0. So from here we can identify a, b, and c. They're not asking us to solve this equation. They're just asking us to find the discriminant. So we know the formula for the discriminant is b squared minus 4ac. It's that number that's underneath the radical. Don't include the radical with the discriminant. The discriminant is b squared minus 4ac, not the square root of that. B squared negative 4 squared is 16 minus 4 times 5 times 2. So that's a negative number because 4 times 5 is 20, and 20 times 2 is 40, and 16 minus 40 is a negative number. So I know that these are complex solutions, that we're not going to get a real numbered answer. Within the set of real numbers, there is no real solution to this quadratic equation, but our solutions are two complex numbers. Now, it did want me to find the value of the discriminant. I was getting lazy by just saying that it was negative. So what? A negative 24. Yeah. Double check me on that. I'm terrible at mental arithmetic. You'll soon recognize that. If you do see mistakes in these videos of me doing arithmetic errors, let me know, because I can come in and make a little edit to let other people know that I've made some computational error. All right, so let's take a look at this last one. We have 1c squared plus 0c. There is no linear term. Plus 6 is equal to 0. So if we identify A, B, and C, that green is a little bit harder to see, isn't it? Sorry about that. A is equal to 1. B is equal to 0. And this C is a constant. It's not the same as the variable, so be careful with that. The discriminant, we know the formula for the discriminant. It's B squared minus 4 times A times C. 0 squared is 0. Minus 4 times 1 times 6. That's a negative 24. Within the set of real numbers, we can't take the square root of negative 24. So this is going to give us two complex numbers like the last problem would have. They're not asking us to find the solutions, but just to state how many there are and what type of solution. So for all these quadratics, we're expecting two solutions. They could be repeated like it was here in number 4, but we still consider that two solutions. And here there's two solutions, but they're both complex numbers because the discriminant, that number that's underneath the radical, was a negative number in both problem 5 and 6. Hope that helps, and I'll talk to you later.